Hello guys, good evening everyone. Welcome back to 360DigiTMG's domain analytics program. I think it is the last session of the domain analytics. At the very first session that we have discussed about what is machine learning and how can we implement the machine learning when it comes to healthcare analytics. And then when the very next day, we have discussed about whenever you are working on some data science project, what are the phases we'll be having? How data science project will be done. So we have something like CRISP-ML, cross-industry standard process. That is a methodology that we will be using in order to do the data science project. That we have discussed what are those phases, and the next day, on the third day, we have discussed about the EDA pre-processing. Once you receive the data set from the client, or even you have done web scraping, after collecting the data frame, how are you going to do the pre-processing? In terms of the text, when you have unstructured data, how you can do the pre-processing? When you have a structured data, how you can do the pre-processing? That we have discussed. And the fourth day, we have taken one unsupervised learning, and we have discussed what are the unsupervised learning, what is supervised learning, what is the difference between them, when we should you go for unsupervised, when you have to go for supervised. That we have discussed supervised and unsupervised. And then we have taken one model from unsupervised learning, that is K-means clustering. We have taken one K-means clustering. Using this algorithm, we have applied one use case. We have taken one use case, that is diabetes prediction. We have segregated the patients of diabetes patients, and then we have taken the KNN algorithm, that is a supervised learning algorithm, KNN. And then we have taken the one use case scenario when it comes to KNN algorithm, that is cancer prediction, whether that particular patient has a cancer prediction, has a cancer or not. Then we have taken the linear regression. For that also we have taken one use case using the waist circumference. We have to predict the adipose tissue that we have discussed. And we have taken the decision tree algorithm as well. Using that, we have predicted the TNBC relapse, triple negative breast cancer relapse prediction, using the decision tree algorithm. So if you haven't watched those videos, please go back and you can go through the 360DG and you will be finding all the healthcare analytics videos in one. Yeah, this is all the things that we have discussed in the previous video. So today we will be discussing about what is the neural networks. What is the neural networks? What are the basic principles we'll be having when it comes to neural networks? How we can, what exactly neural networks? Why the neural network name itself came? So what are the components we'll be having when it comes to neural networks? And how we gonna use that neural networks and will be applying it to healthcare analytics. At the end of the session, we will be taking healthcare analytics, healthcare units. At the end of the session, we will be taking one use case. We'll be taking one use case. Here, we will be having a heart disease prediction. We'll be having heart disease prediction. We will be doing prediction using the MLP, multi-layer perceptron. So what is a perceptron? What is the multi-layer perceptron? All those things we'll see in this class. So yeah, without wasting any time, let's begin the session. So today's agenda, of course, we will be discussing neural networks. What are the neural networks and how can we use the neural networks when it comes to healthcare analytics? And we'll go through neural network primers. That is means we will be going through what are the components we will be having when it comes to neural network. And perceptron, and what is multi-layer perceptron, activation function, what is activation function, error surface, gradient descent algorithm, why we are using the gradient descent. That we will discuss. So guys, when I say artificial neural network, so it seems like it is a familiar word, right? So actually, the artificial neural network is derived from biological neural network, that is human brain. That biological neural network develops the structure of human brain. You can see it is a biological neural network that develops the structure of human brain. Something like that, same like that, we will be having artificial neural network structures will be pretty similar. When you have here we have when it comes to biological neural network, we'll be having dendroids, and we have axon, and we'll be having nucleus, the terminal, and the whole thing will be calling as a body, cell body. But when it comes to neural networks, we'll be having something like X input, X2, X3, neuron, Y is out. So these are all inputs. We'll be having weights, W1, W2, W3. And here we'll be having summation, and we'll be having one neuron, and we'll be having one activation function. You can compare like dendrites, similar like inputs, we'll be having inputs same as dendrites, and you can cell nucleus, it is similar to nodes, we'll be having, and synapse you can compare with the weights of our artificial neural network. So we can simply say the artificial neural network is a mimic. You can say mimic of human brain, biological neural network. Biological neural network. Artificial neural network is a mimic of what? Biological neural network. So why we are using the neural network? We have already have a machine learning algorithms. So why we are going for the neural networks? Basically, in neural networks, we'll be having different layers, something like input layer. We'll be having one hidden layer. And we'll be having output layer. So when it comes to input layer, the name, just like name suggests, it will be accepting the inputs. It accepts the inputs from the programmer, whoever programming that neural network, it will accept the inputs from the programmer. When it comes to hidden layer, it is present in between input and output layers. It performs all the calculation to find the hidden features and patterns. Whenever we are supplying the data, hidden layers, what does? It performs all the calculation to find out the hidden features of the pattern. And then we'll be having the output layers. The input goes through a series of transformation. Whatever the input that we are giving to the artificial neural networks, it goes through series of transformation using the hidden layer, which finally results in an output conveys this. Whichever the input we are giving, so it will go through the different process, and then it will be getting as a output. This is normally how artificial neural network works. So for each input that we are having, it will develop one weight. For each input that we are giving, it will develop weight, and that weight will be multiplied with the input, whatever the input we are giving. And then if it is whatever the input and the weight is greater than that particular value, some particular value, then only the neuron or activation function, whatever activation function will be having, it will shoot. It will be activated. Then we will be getting as a output, whatever the output, whether we are going for the just 2 class, in that case it will be yes or no. If we are going for other classes, it will be dependent on appropriate outputs. So this is the basically how neural networks will work. So we'll be having something like perceptron. So what is the perceptron? In that we'll be having multi-layer perceptron. We'll be having multi-layer perceptrons as well. So what are the things? What is the difference between the unilayer, single perceptron and the multi-layer perceptron? Will see. So like most of the machine learning algorithm that we have discussed, supervised. What is supervised? What is supervised, guys? Whenever the output is known. Output. Whenever you have output in your data frame, in that case, you can apply the supervised algorithm. Since the output is known, you will be applying the supervised algorithm. Just like that, neural network is a machine learning model inspired by the networks of biological neurons. It is also, neural network is also supervised machine learning algorithm. Supervised algorithm, you can say. Just like other supervised algorithm that we have in machine learning, neural network is also a supervised algorithm. So we have 3 types of deep neural network. That is one artificial neural networks that we can also call as a multi-layer perceptron. Using this only we'll be discussing the more about the multi-layer perceptron. We'll discuss, and then we'll be having CNN, that is a convolutional neural, and then we'll be having recurrent neural networks. These are the 3 types. We'll be having one artificial neural network that is also called as a multi-layer perceptron, and then we will be having convolutional neural network, and then we'll be having recurrent neural network. A quick fact: a human brain is made up of about 85 billion neurons. 85 billion neurons. Just imagine how much. 85 billion. When it comes to perceptron, perceptron is also a machine learning algorithm for supervised learning of various binary classification tasks. Further, normally, like we have discussed previously, perceptron is also supervised. Perceptron is also a supervised learning algorithm. So mostly it will be used for linearly separable data set. Mostly it will be used for linearly separable data set. In perceptron, mainly we'll be having these components. Those are input values. We'll be having weights and bias. and we'll be having net sum, and we'll be having activation function. So we'll be having one input values, that whatever the data that we are giving into that neural networks, that is the input values, and we'll be having weights and bias. These are the input values, and we'll be having weights. For additionally, we'll be having one bias, and it is a net sum. We'll be having net sum, and then we'll be having one activation function here. What are those components? We'll discuss in detail. But these are the components we'll be having when it comes to perceptron. Let's see. These are the inputs: x1, x2, x3, x4, and x5. So for each input column that you are giving, for that we will be having weights, different weights. Yeah, something like that. We'll be having summation, weight 1, weight 2, weight 3, weight 4. And then we'll be having a summation. Here we'll be having activation function. It could be any activation function, and then we will be having output. This is the normally perceptron. How perceptron looks like. So here input layer. Here input layer is the primary component of our perceptron, which obviously accept the initial data, whatever the input that we are giving into the system, and then further for the processing. So whatever the input that we are giving, will be given to input data, and then it will accept whatever the input we are giving, and then it will send to the further processing. And when it comes to weights and bias, so whatever the weight that we are assigning, it should be that particular input should be correlated with output. Weight parameters represent the strength of the connection between the units. Weight parameters, whatever the weights we are assigning, it will be the strength or the connection between the units. When it comes to activation function, we have different activation functions. Like when it comes to activation function, we'll be having something like step function. One is step function, and then we have sine function, and then we have sigmoid. Then we have sigmoid function. Step function could be looking like this, step. And we'll be having sine function, something like this. And we'll be having sigmoid. Something. So how does whatever the input that we are giving, how does it process? So whenever you give input into the model, whenever you give input to the model, it will simply multiply that input with weight x1, w1, whatever the input that you are giving, it will simply multiply with that weight. How does a weight decide? Based on the importance of that particular feature. Whichever the feature will be having, based on that important, weight will be decided. And the function will be formed as W1 X1, W2 X2, W3 X3, Wn Xi, sigma Xi and Wi. Whatever the values that we'll be getting, it will be looking like this. Whenever this value with including one bias. So whenever the we are using the neural networks, we'll be having one bias, so that it won't get into the zero value. So neural networks won't be collapsed. That is why we'll be using bias always. Whenever this value is greater than 0, you can say whenever Wx plus b is greater than 0, then only we'll be getting function. That is the output, whatever the new activation function we'll be using, it will be activated. Whenever the Wx plus b is less than 0, in that case, it will be become 0. In that case, the activation function won't be activated. So this is how actually artificial neural networks will work. Whatever the input function, these are the input, different features we'll be having. Whatever the feature that we are giving in a data frame, we'll be feeding into this. And this is how we'll be getting output. If it is just 2 classes, if we have just 2 classes, in that case, it will be just 2 classes, yes or no. If you have multiple classes, in that case, we'll be having multiple. When it comes to multi-layer perceptron, instead of having just one layer, we'll be having multiple hidden layers. So whatever the thing that happening inside this, it is kind of black box technique. So whenever you are applying the multi-layer perceptron when on data frame, it is just like normal supervised learning, the algorithm that we are applying. It is just like normal supervised learning algorithm that we are applying. Just import those. I'll show you this. Additionally, when it comes to single layer perceptron and its multi-layer perceptron, we'll be having back propagation whenever input and weight will be multiplied. If there is any error, in that case, the whole with error it will be supplied into back to the algorithm. Again, there will be same process. We'll be having back propagation when it comes to multi-layer perceptron. Whenever we are having the multi-layer perceptron, we'll be having back propagation. Multi-layer perceptron is a supplement of feed-forward neural network. It consists of 3 types of layers. That is input layer, output layer, and hidden layers. Whatever the things that are happening in hidden layer, it is kind of black box technique. The input layer receives the input signal to be processed. The required tasks such as prediction and classification is performed by output layer. The number of hidden layers that are placed in between the input and output layers are true computational engine of multi-layer perceptron. So the number of hidden layers that you can design, how many number of hidden layers you want to, but when it comes to input layers, the number of features you will be having. The number of features you will be having in your data frame, that only we will be taking as a input for this particular layer. So like we have discussed earlier, we will be having some step function and RAM function and segment function. These are the different activation layers we'll be having in order to get an output. We'll be having one cutoff if it is greater than that particular value. In that case, that particular activation function will be activated and then output will be given. If it is less than that, in that case, it won't be activated. So one thing, how does multi-layer perceptron calculate the error function? For that, it will be using the gradient descent function. Gradient descent function. So here we'll be having minimas, local minimas, local maxima, global minima, and global maxima. Whenever the value, what is the random values we are taking? If it is start from here, it will reach global minima. Then only the error function. The error function that we are getting will be as low as possible. Whenever it reaches the global minima, that then only the error function that we are getting will be the low, and the accuracy of the model will be maximum. Yes. And when it comes to use case, guys, we'll be having one use case, that is heart disease prediction. Heart disease prediction. We'll be having different features. We'll be importing the MLP, that is multi-layer perceptron, and then we'll try to fit the whatever the data frame that we'll be getting, and then we'll predict whether that particular patient is gonna get the heart disease or not. Yeah, this is the data frame for our model. We'll see the description of these particular columns, and these are the plots that we are getting. Seems like most of the time we don't even have data. Here it is kind of normal data, but not completely. And here we have a slightly right skewed data, and we are here also cholesterol also will be having slightly right skewed. And here FBS we don't even have data in terms of Talash. We'll be having a better kind of normal data. We'll see what exactly are these. When it comes to correlation, we don't really have any strong correlation when it comes to input variables. So we can go ahead with it. We don't have any collinearity issues. Okay, proceed with the model. So when it comes to description of our model, we'll be having systolic blood pressure, that is SSB, we'll be having, and tobacco, cumulative tobacco, whether that particular person has tobacco or not. Low density ibuprofen cholesterol, adiposity, and we'll be having history of heart disease in the family, whether that particular patient ancestors having that particular disease or not. Then type A, type B behavior, and obesity if that particular person has obesity. Current alcohol consumption, whether that guy having the alcohol consumption or not. Age and the CSD response. These are the input variables we'll be having. Based on that, we have to predict whether that particular person is gonna get the heart disease or not. So this is a data set. It is a publicly available data set. You can simply go to this site and you can download the data set, guys. Yeah, what is yeah, for the very beginning, I am importing all this pandas library, NumPy, Seaborn. So why we are using the pandas library, like we have discussed in the last session while we are doing the use case scenario, in order to do the manipulation, whatever the changes you want to do when it comes to data frame, we have to use pandas. NumPy, if you want to do any mathematical operation, in that case, you will be using the NumPy. When it comes to Seaborn, in order to do with advanced visualization, in order to do advanced visualization, we'll be using Seaborn, or you can use Matplotlib as well, but it is for a basic visualization. Anyway, we'll be importing that to calculate the box plot, whether we have any outliers or not. So we are using that. So obviously, we have to do the pre-processing. So here we are, taking the columns of SBB, tobacco, ideal, adiposity, type, obesity, alpha. These are the columns we'll be considering as whenever you see the data set. This is the data set we'll be having. Whenever you describe, what does describe function do? It will simply show what will be the mean, what is the mean, what is the median or mean, standard deviation, minimum value and maximum value, and how many values are present in 25 percentile, how many values are present in 50 percentile, and how many values are present in 75 percentile. And I'm checking whether we have any null values or not in our data. We don't have any null values. If you have in case if you have found any null values, you can do the imputation. But like we are working on healthcare analytics, so please look if it is makes sense. Whatever the imputation that you are doing, is it making sense or not? Based on that, you can go for imputation. If it doesn't make any sense, in that case, wherever you're having the null values, you can simply remove it. So if you have any categorical values, we have to convert into. Do you have any categorical values here? We don't really have. Yeah, here we have numbers. For that, we have to convert into label encoding. Since we have these are the values, we have to do label encoding for that. Once we have done the label encoding, it will be converted into 0 and 1. Since we have just 2, that is 1 and 2, in that case, we will be doing the label encoding. And here we are doing the scalar normalization. Why we are doing the normalization? Since there is a huge difference in between the input variables. Here we have SBP 120, and here we have just 0 and 1. It is we have just 5. In order to bring all those in just single scale, we are converting into min-max. Using min-max scalar, we are converting into normalization. After doing normalization, this is the value that we are getting. So here we are visualizing the data, whatever data we'll be having. All we are simply visualizing SPP, tobacco, ideal, adiposity. We'll be using the Matplotlib, and we are visualize. You can see the range of values will be having various values across the data frame. First 50 values. We just taken the first 50 values and distribution of obesity according to the age. You can see obesity of a particular age, like 40. Here you can see at the age of 50, most of the people having the obesity. Most of the people who are at the age of 50 have the most. And you can see here distribution of alcohol consumption across the age. You can see most of the people who are in between 20 to 60, most of the people are having the alcohol consumption. Histogram for all the columns that whatever the columns will be having, for all the columns, the histograms. You can see most of them are not symmetric at all. And then we are going for box plot. Why we are using the box plot? To check whether we have any outliers or not. Here I couldn't find any outliers since and then we are doing the heat plot. Heat map, you can say. Why we are doing the heat map? To find out the correlation. Find out the correlation. Here, mostly we don't have any correlation. And then we are importing the from sklearn package, sklearn metrics, import makes for accuracy in order to evaluate the model, whatever the model we are building. To evaluate that, we'll be importing the accuracy score, and then we are model selection, import grid search CV. Let's see. When we'll be using the grid search CV to bring out the best parameters. And we are importing the neural network MLP classifier. Here we are defining the MLP classifier. In that, what we are doing, parameter solver, we are using the LBFG, and alpha we are taking. Hidden layer size we are taking 9, 14 and 2. Here we have 2 hidden layers. Each hidden layer will have layers of 14 neurons. And 9 inputs we have. Whatever the inputs we are taking, we have 9 inputs. And random state is equal to 1. Whatever the values that we are taking, we are randomly taking. Yeah, we are using the evaluation metric. I mean, we have imported the accuracy score, right? That only will activating and to get the output. The same we are doing a test, and we are doing on a train. This is the confusion matrix we have. This is the confusion matrix. So these are true cases and these are misclassified cases. misclassified. These are the true cases and these are misclassified cases. So we have here more misclassified cases. In that case, what we have accuracy, that is a 76. So whenever you have misclassified case, you should go for precision recall, and we don't know whether the data is balanced or imbalanced. So we can go for precision recall. We are getting 86 and 73, so it is okay. I mean, the kind of yeah, it is pretty good value when it comes to precision and recall. So if you want to improve that model, you can go for dense layer, or you can use Keras library and you have to improve the same model. But here we are simply taking the very basic model, or you can say base model, and we've tried to build that base model. So if you want to improve that model, you can simply go for Keras and you can build your own to increase the accuracy of that particular model. So when it comes to neural networks, you need a lot of data to train. The more data you have, the more accuracy will be. I mean, you can easily improve the model accuracy. The more data, neural network requires a lot of data to train that particular model. Then only you will be able to increase the accuracy. Yeah, that is it all about the neural network, guys. If you want to improve the model, or if you want to get the data set of this model, you can simply go to this site. You can simply download the data set. It is open. I mean, you can easily anybody can able to download data, and you can simply work on this model. So this is all about artificial neural network, and how can we apply the same artificial neural network when it comes to healthcare analytics. We have taken the use case scenario, and that is heart disease prediction, and how can we apply the same artificial neural network in healthcare analytics that we have said. If you want to kickstart your data science career, you can from July 11th. From July 11th, 6:30 to 7:30. Python classes are starting in 360DG YouTube channel, 360DigiTMG YouTube channel. If you want to kickstart your data science career, you can simply join, and you can start your journey. That is all for today, guys. I hope you have learned something, and yeah, I will see you next class. I think it is it is the last session of the domain analytics and conceptual healthcare. So we'll see you in the next session with one more domain analytics, and yeah, have a nice